Hi, this is Rashekar Iligar, Instructor, Electronics and Communication Engineering Department, GM Institute of Technology, Davangere. Today I am going to rig up the circuit plus 5 volts DC power supply circuit using a bridge rectifier, capacitor filter, and finally using the regulator 7805. For our circuit, the components required is, this is the circuit what I am showing you, plus 5 volts power supply unit using bridge rectifier, capacitor filter and IC 7805. These are the list of the components what we require for this circuit. The transformer, whether you take 90, 90, 12, no problem. So diodes, 4 diodes, that is 1N007, and the capacitor electrolytic I have taken 470 microfarad, and the capacitor ceramic, 2 capacitors I have used 0.01, the number is 103, and the regulator IC is 7805, and the connecting wires and the breadboard. So these are the components you require. Just go through this. These are the list of the components, and this is a circuit diagram. Here it is a transformer step down, and it is a primary winding, and this is secondary winding. So input for this primary winding is 230 volts AC, 50 Hz, and output at the secondary winding 12-0, since the transformer is 12-0 rating. And this is the bridge of the diodes. 4 diodes we have used. This is the diodes connected in bridge form, and it is a capacitor 470 microfarad, and these are 2 ceramic capacitors, and it is a regulator IC, and finally it is plus 5 volts at this point at the pin number 3. And also the pin node diagrams. So this is a diode symbol, and physically the diode, how you have to identify is, whenever you are observing the diode, if there is a silver strip, that is a cathode, and opposite that will be anode. For electrolytic capacitor, this is a symbol for physical identification. So this is the minus sign, it is there. Otherwise you have to observe the length of this thing pins. So whichever is lengthier one, that is a positive, whichever is short length, that is a negative. If they are having same length, if it is in some case, you just go through this minus symbol. This is electrolytic capacitor, and it is a diode. And there is a strip, that is a cathode, the anode, and these two are ceramic capacitors, ceramic capacitor, and it is a regulator IC 7805. So identification pin is very simple. Pin number 1, 2, 3, 1 is input, pin number 2, that is the middle one, is ground, and the last pin is 3 is output. So this is a capacitor and the regulator IC, it is a diode, and it is a ceramic capacitor. These are the main components you have to use for this circuit. Now I will show you the connections. Initially I will show you how to connect the bridge on the breadboard. This is important. You know that it is anode and it is cathode. In physical component, there is a strip, a silver strip, that indicates a cathode. The opposite side is anode. So I will connect the diodes like this: anode, cathode, and one more diode I will place like this. Anode, cathode, anode, cathode, and other 2 diodes in the same vertical slot you have to consider. Here also in the breadboard, you know that this vertical path is shorted. Anode, cathode, this is anode, cathode, anode, cathode, anode and cathode. So now the bridge is ready. Now the next step is you have to connect the capacitor along with two more capacitors, one regulator IC. I will put capacitor here. Capacitor. You know, in the breadboard only 5 slots are shorted. I will make these 2 slots. Take this as a ground line, bottom one. This I will make a short by using the connecting wires, and capacitor positive wire, it is connected to the point where the two cathodes of the diode shorted. This point here, it is that point, cathode. From here to here I will take one wire, and this is go to one common ground, this point where the two anodes of two diodes is shorted. Here it is there, this point will connect it to the common ground. Next, regulator IC I will put here. You know that pin number 1, 2, 3, pin number 2 is ground, 1 is as a input, 3 is output. From pin number 3, I will show you with the help of connecting wires. Pin number 3 can connect it to this capacitor using this wire, this connection, and pin number 2 directly it is being grounded. I am grounding pin number 2 of the regulator IC to the ground, and pin number 1 to the another capacitor that is also grounded. Can directly ground here this capacitor. So this connections is over. So pin number 1 there is a capacitor, 2 it is a ground, 3 it is one more capacitor, it is been grounded, 0.01 capacitors. So input for this regulator is pin number 1 to this. I will take one wire and show you. Here it is been connected. To make the circuit clear, I have used these jumpers, wires. Also the circuit is ready. It is a common ground. Now I have to connect the transformer and I have to show you the output. So transformer will come to this and this point. From this point there is a transformer 112 voltage line, and it is this point we have to connect to the zero line. Start. So this is a transformer, primary of the transformer. This goes to AC mains 230 volts AC, and this is the secondary of the transformer. So these two wires, I am going to connect this to the bridge at this point, cathode point. This is where you have to connect where the cathode and anode point is shorted, and another zero line, it is cathode and anode point. Here it is opposite point. So now the transformer connection is over. So with the help of multimeter we can check the final output of our this power supply. So multimeter you have to keep it to DC volts mode, since we are checking output DC voltage plus 5 volts. DC mode you have to keep it, and this is the positive terminal of the multimeter, and I am connecting the output at the regulator output across this capacitor. One terminal positive terminal, another terminal it is to the common ground. Now I am going to switch on the mains. So there you are getting the expected voltage, that is 4.93 volts. 5 volts it is the expected voltage, it is coming 4.93 volts. So thank you for watching my video. Please subscribe my channel for interesting videos like this based on related to electronics. Thank you.